Welcome to The Explainer. Today, we're diving headfirst into the incredibly complex architecture of Armageddon. We're going to break down the layers of science, engineering, and sheer strategy that make up the absolute most powerful devices humanity has ever engineered.
Right off the bat, I want you to picture something for a second. What exactly is inside the world's most powerful weapons? Like if you were to strip away the massive missile silo, the stealth submarine, or the heavy bomber, and just look at the payload itself, what would you actually see sitting there? Just picture the absolute center of these devices in your mind's eye.
You know, it's incredibly easy to picture a nuclear bomb as just, well, a giant stick of dynamite waiting for a spark, but actually, scratch that. A modern nuclear warhead is far more than a simple explosive device. It is a highly complex strategic system. What we're really looking at here is the absolute pinnacle of nuclear physics, advanced materials, and precision engineering.
Section 1. Anatomy of the core. Okay, so to actually produce that enormous release of energy we associate with a nuclear explosion, you need a highly precise step-by-step sequence. It's like a microsecond ballet. First, the weapon has to receive an authorized command. Then, conventional high explosives detonate with microsecond precision. This isn't just random packing. It's an intricately designed mechanism that acts as a flawless, perfectly timed trigger. It's literally only through the exact detonation of these conventional explosives that the core is rapidly compressed, which finally allows the nuclear reaction to begin under very strictly controlled conditions.
Section 2. Systems of Safety. Now, if we zoom out from the core itself, we run into this really fascinating paradox. The deadliest weapons ever conceived by human minds actually require the world's most advanced safety systems to make sure they don't detonate accidentally. Surrounding that nuclear core are multiple technological barriers designed to keep the entire weapon completely inert until it's explicitly authorized. You've got the safety and arming system, which actively prevents unintended activation. Then there's the fuzzing system, using super sophisticated sensors and control electronics to figure out the exact conditions under which the warhead is actually meant to function. And encasing that whole thing, a robust protective structure designed to survive extreme environments. Every single layer is built to ensure the weapon remains totally safe, secure, and reliable.
Which brings us to one of the most critical concepts in modern nuclear tech, permissive action control. This broadly refers to these security mechanisms specifically intended to prevent unauthorized use. Think of these as the ultimate fail-safe technological locks placed on the weapon. Even if someone somehow gained physical access to the warhead, these advanced electronic systems are designed to completely resist tampering. They ensure the core absolutely cannot be initiated without the proper, highly encrypted codes and authorizations. No codes, no boom.
And all of this ties into a massive overarching concept called nuclear surety. This encompasses the comprehensive safety, security, reliability, and control measures associated with nuclear weapons. It's the whole shebang that guarantees the weapon remains secure throughout its entire lifespan. Because remember, it's not just about the moment of detonation. These systems are absolutely critical because the weapons have to remain perfectly secure and reliable while they're just sitting in storage, being transported, undergoing maintenance, or in active deployment.
Section 3. Delivery and Reentry.
So, obviously, a warhead doesn't just magically teleport to its target. It can't be separated from its delivery system. Take an Intercontinental Ballistic Missile, or ICBM. That is an incredibly complex vehicle in its own right. It combines heavy propulsion to launch it into space, highly advanced guidance systems to direct it, communications and command and control to receive orders, and finally, a re-entry vehicle. The actual warhead payload is integrated directly into this vehicle for the journey.
Now just imagine the environment this vehicle operates in. As the re-entry vehicle plunges back toward Earth at thousands of miles per hour, the atmospheric friction creates intense aerodynamic heating. We're talking temperatures that can briefly rival the surface of the sun. Surviving that fiery return to Earth requires highly specialized materials and incredibly advanced thermal protection systems. Because without them, the sophisticated warhead inside would just be completely incinerated before it ever got anywhere near its destination.
This whole delivery concept evolved in a massive way with MARVs, multiple independently targetable re-entry vehicles. Basically, this technology allows a single missile to carry multiple warheads, with each one riding in its own separate re-entry vehicle. So instead of one missile carrying one bomb to one target, militaries figured out how to maximize a single missile's payload, sending multiple warheads to entirely different targets at the exact same time. And looking toward the nuclear warheads of the future, these re-entry vehicles are evolving into even faster, highly maneuverable hypersonic glide vehicles specifically designed to evade modern defense systems.
The development of MIRV technology was an absolute game-changer. It drastically altered global military calculations and strategic nuclear planning during the Cold War. It basically multiplied the destructive potential of existing missile fleets without anyone having to actually build more missiles. It fundamentally changed the math of nuclear standoffs.
Section 4. The Paradox of Deterrence. To truly wrap our heads around these weapons, we have to look at this incredible engineering marvel through the lens of global politics and human psychology. Because the core strategic doctrine here is deeply paradoxical. As this quote hits the nail on the head, their primary strategic purpose is generally not to be used, but to discourage an opponent from launching an attack. They are meticulously built, tested, and maintained with the absolute hope that they are never, ever detonated in conflict.
And that creates this profound, almost unthinkable tension at the very heart of nuclear strategy. The more destructive the weapon becomes, the greater the potential consequences of using it. Nuclear deterrence relies entirely on this terrifying dynamic. It's built on the idea that the threat of catastrophic, world-altering retaliation can prevent a nuclear conflict from ever kicking off in the first place. The sheer horror of the weapon is literally what's supposed to keep the peace.
So as you can see, understanding a modern warhead is about so much more than just physics or the anatomy of a core. The internal technology is just one piece of a much larger ecosystem. Behind every single warhead are massive layers of science, brilliant engineering, airtight security protocols, rigid military doctrine, and incredibly delicate international politics. And as we look to the nuclear warheads of the future, these layers are only going to grow more complex, integrating things like artificial intelligence into surety systems and navigating totally new frontiers of digital and cyber warfare, all just to maintain this fragile balance of global security.
Ultimately, the story of the nuclear warhead is a story about the staggering, awe-inspiring power of human science. But perhaps the most important question isn't just how these complex, terrifying weapons work. The real question is, given the enormous responsibility that comes with possessing such destructive technology, how can humanity ensure that they are never actually used? I want you to take that thought with you today. Thanks for joining me for this explainer, and I encourage you to keep questioning and keep learning.